We are starting with the fourth lecture of vectors. The first two lectures, they were about the concept of column vectors and the related past paper questions. The third lecture was about the basics of vector geometry. In today's session, we would be focusing on past paper questions of O-level math, CAIE syllabus code 4024. Now let's look at a question from the 90s. It says OABC is a parallelogram. The point X is on AC such that AX is 1/5 of AC. Can you see where X is? There it is. AX is 1/5 of AC. So let me write it. AX is 1/5 of AC. In other words, I can also write AC is 5 times AX. I have just multiplied on the other side. Now let me grab my markers. Grab a black one, purple one, and an orange. The second piece of information is the point Y is on AB such that I can see the Y, such that AY is 1/4 AB. AY is 1/4 AB. In other words, AB is 4 times AY. Now this thing is written down. What else should I write? Before I write something else, can I write, if that's not needed at this point, if needed, then I'll write it. Given that OA is 20p, so OA is this line, that is 20p, and OC is this line, that is 20q. This is 20p, this is 20q. Since it's a parallelogram, OA is the same thing as CB, and OC is the same thing as AD. So this is by definition that it's a parallelogram. First, they are asking us to find what is AC. Now, in order to find AC, we have to do the triangle method. That is OA plus AC is the same thing as OC. Let's move to the next page. OA plus AC, look at the direction of the arrows. OA, AC, that is equals to OC. So OA plus AC is equals to OC. Make AC the subject. That's OC minus OA. OC is 20Q. OA is 20P. I can take 20 common out if I need to. That is 20Q minus P. Put the arrows where they belong. This is the first part. Now the second part is they are asking us finding AX. We have this piece of info that AX is 1/5 of AC. Let me cut it and put it over here. AX is 1/5 of AC. So second part, AX is 1/5 of AC. AC is this much. That's 1/5 of 20 of Q minus P. That is 4 times Q minus P, which can be written in the simplified form, which can be written as 4Q minus 4P. AX is done. Third, it's asking for OX. Now, let me choose another line, another color, maybe purple. OA plus AX is equals to OX. OA plus AX is equals to OX. So the third part, OA plus AX is equals to OX. OA is given as 20p. AX is given as 4Q minus 4P. I've opened up the bracket, is equals to OX. Therefore, OX is equals to 4Q plus 16P. Double check the working. Go from O till A. Go from A till X. The shortcut, the resultant is OX. So OA plus AX is OX. Done? What's the fourth part? Fourth part is OY. Now, what can I do with OY? The working is, first, let me write it. OA, let me choose another color. OA plus AY is equals to OY. Do we have OA? Yes, that is 20p. Do we have AY? We have the relation AY is 1/4 of AB. So AY, let me write it at the bottom. AY is 1/4 of AB. AB is the same thing as OC. So that is 1/4 of 20Q, which comes out to be 5Q. So AY is 5Q. That is equals to OY. So if I simplify, OY is 20P plus, let me write Q first, 5Q plus 20. Now, the last part. What do the results of part 3 and part 4 tell you about OXY? So let me write the result over here. What is OX? 4Q plus 16P. Let me copy paste. This is OX and this is OY. Now, one is the answer for part 3, that is OX. The other is the answer for OY, which is part 4. What do they tell you? Now, they don't tell us anything unless we simplify. Let me rewrite OX. OX is 4 common Q plus 4P. OY is 5 common Q plus 4P. Am I right? I can write OY in terms of OX. I can write OX in terms of OY. How? Simply divide. OX divided by OY, that is 4Q plus 4P. That is 5Q plus 4P. Therefore, OX is to OY is 4 is to 5. Remember, when we studied vectors, we said if one vector is a scalar multiple of the other, that means the vectors are parallel. Therefore, I can write it in two ways. I can write OX is 4/5 of OY, or I can write OY is 5/4 of OX. It's the same thing. The diagram is not drawn to scale. If the examiner would have drawn a better diagram, technically, this point is Y. That means the vectors are parallel. If they are asking about vectors, we would say they are parallel vectors. But they are asking about OXY. Remember, when we study collinear points, points lying on the same straight line, For example, this is A, this is B, this is C. When we talk about coordinate geometry, we would say gradient of AB is the same thing as gradient of BC is the same thing as gradient of AC. But when we talk about vectors, we would say that vector AB is parallel to vector BC, it's parallel to vector AC. So now coming back to this, since we have proven that the vectors are parallel, in other words, O, X, Y are collinear points. So this was a question from November 1990. Many years back, but a question well worth it. Some of these 90s questions are too good in concept building. Some of them are too difficult that will make you lose hope. So you have to stay between the two. So this was the first question that we studied today. Have a look at it. The relationship that was given, I twisted it around. AX is 1/5 AC, AC is 5AX. AY is 1/4 of AB. In other words, AB is 4 times AY. Then what I have written at the bottom, because it's a parallelogram, opposite sides are parallel as well as equal in length. Therefore, in terms of vectors, they are equal vectors. Then this actually was the last part. This is what we get started. We got started with OA plus AC is OC. We made AC the subject. Second part, we found out what is AX based upon the ratio provided. Third part, we drew a triangle ourselves, a triangle of vectors, head to tail method, OA plus AX is equals to OX. Similarly, OA plus AY is equals to OY. And then we talked about what's the relationship between OX and Y. OX and OY, after taking the constants common out, when you divide, the vector portion gets cancelled. OX over OY is 4/5. In other words, OX is 4/5 of OY. OY is 5/4 of OX. If vectors are parallel to one another, that means they are collinear points. Now let's move on. All of a sudden, you see some angle properties. We are interested in polygons. Remember that in polygons, what have we studied? The smallest polygon is a triangle. When we talk about sum of interior angles, we study that n is the number of sides, n minus 2 into 180 degrees. If it's a regular polygon, then each interior angle is the sum divided by n. Let's talk about a hexagon, a 6-sided polygon. Sum is equal to 6 minus 2 into 180 degrees. That is 4 into 180, which is 720 degrees. If it's a regular hexagon, therefore each interior angle is 720 degrees divided by 6, which is 120 degrees. Right now, I just want to focus on this. This is something scary which you don't need as such. If I consider this diagram to be a regular hexagon, that means all these angles, let me first copy it. Let me change it into a white background. If I copy it and put it on the next page, I might need to use it again. So therefore, this angle is 120, this angle is 120, this angle is 20, and all these angles are 120. Now, what I do is that let me draw lines such that till the center. It's not a very perfect diagram, far from perfect. This angle is 60 degrees. These two lines are equal in length because all the sides are equal in length. Therefore, what you get is 60 degrees and 60 degrees and 60 degrees and 60 degrees and so on. You get 6 equilateral triangles. If this is A, B, C, D, E, F, and this is O. Triangle AOB, triangle BOC, triangle COD, triangle DOE, triangle EOF, and FOA. All these are equilateral triangles. Keep that in mind. Now, if I talk about this length, the purple length, and if I draw in green or blue, if this length is A, if this length is 1 unit, this is 1 unit, this is 1 unit. If I extend this blue line, it's not drawn to scale. Let me make it a bit better. If these two lengths are equal, if this is 1, equilateral, this is 1, this is 1. If I extend this like this, it's not drawn to scale. This is also 1. And this is 1. Agreed? This is 1 because it's a regular hexagon. So all these lengths are 1. The main thing that I'm trying to say is that if A, B, C, D, if AD is 2 units, then because of geometry, FE will be 1 unit and BC would be 1 unit. Those two were 1 unit anyways, but AD would be 2 unit. Now, how is it useful in this particular scenario? In this diagram, OABCDE is a regular hexagon. OA is A, OC is C. Now, let me remove the colors for right now. What is OA? That is A. What else is OA? DC is OA. So let me label it. This is A and this is A. Now, do I know OE? No. Do I know BC? No. Do I know AD, ED, AB, or OC? I know this one for a fact. This is C. And just over here, I've studied that if in a hexagon, if AD is 2 units, FE and BC are 1 unit each. That means OC is like 2 units. So OC magnitude is 2 units. Therefore, AB magnitude would be 1 unit, and that would be the same thing as ED magnitude. Agreed? That means if OC is C, therefore AB should be half of that in the same direction. That's half C. And what else is half C? ED. So I've answered AB. I need AB for one of the parts. I think for the last part, I need it. Let's first write what is CD. CD is obvious. That is A. What is AC? AC is simple. OA plus AC is equals to OC. Therefore, if I make AC the subject, that is OC minus OA. OC is C and OA is A. Have a look. Only in the last part, they have used the concept of the geometry of a hexagon. How do I find OB? I cannot find OB unless and until I have AB. If I have AB, I can say OA plus AB is equals to OB. Let's look at it again. OA plus AB is equals to OB. There it is, AB, based upon the ratio from geometry. It has nothing to do with vectors. It has everything to do with basic geometry. Therefore, OA is A, AB is half C, that is equals to OB, and that's how OB is found. Clear? Let's look at the mark scheme. The first part is A minus A. Why? Because they're asking for CD. My bad. DC was A. Therefore, CD is minus A. CD is minus A. I forgot that minus sign. Direction makes a difference. And then part 2 is C minus A. Part 2 is this one, C minus A. And part 3 is A plus half C. Part 3 is A plus half C. Okay. Now, let's look at question number 40. On a grid in the answer space, OA is equal to A. There is the small OA. And let me make it a bit thinner. This one also. OA is equals to A. And let me make it blue. OB equals to B. Now, what does it say? On the grid, mark clearly the point OX starting from O going till X, such that 3B minus 2A. So 3B means go up along that angle 3 units. So this is again 1B and then 2B and then 3B. This is 3B. This is A to the right, but I want minus 2A. So 1 unit, 2 unit, like this. This is where it stops. That is your X, because this is 3B and this is minus 2A. So 3B minus 2A is actually 3B plus minus 2A. So I first drew 3B, then added to it minus 2A. We all are aware of how minus 2A would look like. It would be double of A, but in the opposite direction. Now it says, write down OY in terms of A and B. For each part, I need a new diagram. How would I reach OY? I would go, first of all, let me look at the color. So the color is, I think, blue. For this one, orange. This one, A is orange. And the blue is this one. And let me label over here. The blue is this one. And the orange is this one. Now, OY. That means let me first go down. So from O1, 1, 2, 3. So 3 down, that is minus 3B. And the orange vector, only 1 unit to the left. That is minus A. So basically, O till Y, that is 3 units down, minus 3B, 1 unit left, that is minus A. That is the vector O. Let's look at it again. Minus 3B, minus A. So OY is minus 3B minus. Now it says it is given that OP is A plus NB, where N takes all the values from minus 3 to 3. On the grid, draw the locus of point P. Now let me rephrase this question. If the question says where N takes all integer values from minus 3 to 3, that means OP could be A plus 3B. OP could be A plus 2B. OP could be A plus B. OP could be A plus, this is 1B, this is 0B. OP could be A plus minus 1B. OP could be A plus minus 2B. And OP could be A plus minus 3B. Done? That means that point A plus 3B would be, let's start with A plus 0B. This is the 0B. This is A plus 1B, A plus 2B, A plus 3B, A plus minus B, A plus minus 2B, and A plus minus 3B. So if I label this as 0, so this is 0, and this is 1, and this is 2, and this is 3, and this is minus 1, minus 2, minus 3. Let me say it. This is the 0, this is 1, this is 2, this is 3, this is the minus 1 value, this is the minus 2, this is the minus 3. Done? But the examiner does not say integer. That was my improvisation. The examiner says all values. That means the values could be decimals, the values could be fraction, it could be 2.5, it could be 2.14. That means it could be any which value. So what is the answer? The locus would be all these points up there. Therefore, the thick, fat blue line is the answer, because locus, what does it mean? Locus means set of all points fulfilling a certain criteria. Loci is singular, locus is plural, set of all points fulfilling a certain criteria. So that point P could lie anywhere along this blue line. A is simple. A is simply A. Then it could be A plus half A plus 1/3 A plus 2A, A plus 3A, A plus 1.5A. So it could lie anywhere on this thick, fat blue line. Done? Okay. Now let's move on. The line drawn or 7 points on the locus, including the endpoints. The line drawn through the 7 points on the locus. And of course, including the endpoints, that means you should stop at these points. Okay, another question. On the grid, in the answer space, OP is P and OQ is Q. Now that grid was not provided. Maybe I did not copy it perfectly well. Mark clearly such the point. Let me just double check if that thing is still there. Question 41. So mark scheme. So 79 and 41. No, the part is missing. So I don't think so we would be able to do it unless I find the original question, because it doesn't make a difference where P is going and where Q is going. So let's skip this question for right now. We will do it in our next session. Skip for next session. Okay. Now, what I'm trying to teach you now is that a bit of similarity. Now, all of the math is interconnected. Okay? You must be tired by now, just studying 25 minutes. But take a deep breath and get energized. There are things in maths which, of course, are interlinked. When you are studying vectors, all of a sudden, polygons just came in. Basic concept of geometry just came in. Similarly, when we deal with vectors, similarity does come in a lot. Now, if I look at this question, and let's forget about vectors, let's relax, thoda sa thande ho jaye. Or if I look at this question, I see two triangles. One triangle is ABE, the other triangle is ACD. So I see a triangle ABE, and I see another triangle ACD. Can I take it for granted that these two triangles are similar? I can take it for granted with only one condition. They are similar, provided line BE is parallel to line CD. So let me make it parallel, and that is the beginning of similarity. Why are these similar? Because this angle, whatever that is, this angle is common. Then this angle and this angle is common. Then let me choose a green color also, orange is good. Then this color, this angle and this angle is the same. So this angle was common. Purple equals to purple and orange equals to orange. Done. If I want to write the relationship, I can say the ratio of BE is to CD should be the same thing as the ratio of AB is to, not BC, that's wrong. AB is to AC, because you are dealing with triangles. BC is not the length of any triangle. BC is the length of a trapezium. You're not dealing with trapezium right now. So AB is to AC is the same thing as AE is to AD. Think, ponder on it slowly, gradually. Why were they similar? The small triangle and the big triangle, why were they similar? Because there was a common angle. The corresponding angle ABE and ACD were the same. The corresponding angle AEB and ADC were the same. And if someone has in mind what are corresponding angles, there is nothing to worry about. I can still teach you that. This is one line. This is the other line. This is another fat, thick line like this. This angle, if it's A, this angle, it's B. So A and B are corresponding. A is the same thing as B, provided the blue lines are parallel. What about alternate angles? This angle C and this angle B, they are alternate because it's forming a Z shape. Anything else? Let me write one more angle. This orange angle. Yeah, let me choose another color. Let me choose blue. This angle, let's call it M. Okay. A plus K adds up to 180 degrees because angles lying on a straight line, supplementary angle. C plus K also adds up to 180 degrees, no big deal. Now, A and B are the same, remember? This one. Therefore, if I choose the first line, A plus K equals to 180 and replace it with B. So therefore, B plus K is also 180 degrees. So these two angles, B and K, one acute, one obtuse, adding up to 180 between two parallel lines, These are called interior angles. These were corresponding angles, not crisp angles, corresponding angles. And these two are the Z shape, the alternate angles. So that is the property for two parallel lines: interior, corresponding, and alternate angles. Coming back to this, everyone clear on this scenario? Now, if I ask you, what is the length of CD? Can we find it? Yes, we can. What is AB? Let me write it again. AB is to AC is the same thing as BE is to CD. What is AB? 2. What is AC? 2 plus 3, which is 5. What is BE? 4. What is CD? CD is what you're looking for. So therefore, 2 divided by 5 multiplied by 4 is CD. Okay, let me just double check it. No, that's not CD. That's written upside down. Therefore, CD is 4 into 5 divided by 2. That is 20 over 2. That is 10 centimeters. So the length of CD is 10 centimeters. Now, even a more important task, of course, related with similarity. If I ask you, if I give you that this angle is theta, it's unknown this angle is also theta. What is the ratio? What is the area of triangle ABE in terms of theta? Let me first write it. That's half into 2 into 4 into sine of theta. Similarly, area of triangle ACD, that is half into 5 into AC is 5 and CD is 10 sine theta. If I ask you, what is the ratio of areas of triangle ABE to triangle ACD? So you would say half into 2 into 4 into sine of theta, and then half into 5 into 10 into sine of theta. Now, whatever was theta, we don't need the value as such, because the sine theta and the sine theta gets cancelled. The half and the half gets cancelled. 2 into 4, that is 8. 5 into 10, that is 50. That comes out to be 2 4s are 2 25s. This answer is 4 over 25. Done. That means the ratio of the small triangle to the big triangle is 4 is to 25. Now, just on the side, if I ask you, what is the ratio of AB is to AC? Or what is the ratio of BE is to CD? So you would say that was 2 is to 5. Remember in the first working, this is 2 is to 5. When CD comes out to be 10, 4 is to 10 is also 2 is to 5, because that is the assumption on which your working started. Is there any relation between 2/5 and 4/5? If I square 2/5, I get 4/5, 4 over 25. If I square root 4 over 25, I get 2/5. That means we know this from a fact that the ratio of triangle area of similar triangles. Let me write it properly. Ratio of areas of similar figures is actually ratio of their corresponding lengths squared. That means area of triangle ABE to area of triangle ACD is simply the ratio of AB is to AC squared. You don't have to carry out the whole working. That is 2:5 whole square. That comes out to be 4:20. So now this extra knowledge was required, because if these two triangles are similar, the ratio of the areas is the ratio of the length squared. This is about similar triangles. Now, if I ask you, hence, what is the ratio of area of triangle ABE and area of trapezium BCDE? You don't need any formula for trapezium. It's based upon the previous part. 4:25, what does it mean? Think for a second. It means this region, if I shade it, if I shade this region, it's not drawn to scale. And if I shade this region, this whole triangle is 25, out of which 4 is over here, 21 is over here. Make sense? 4 out of 25. The bigger triangle was 25 in the simplest form. So the smallest triangle was 4/25 of it. So 4 out of 25. That means the trapezium is 21. Hence, I have answered your question. AB is 4. Therefore, trapezium is 20. So this is 4, this is 21. Altogether, that's 25. So area of triangle small to trapezium is 4:21. Similarly, if you ask me the question, what is ratio of area of triangle ABD to area of trapezium BCDE? The whole triangle was 25 and the trapezium was 21. Of course, we can write it this way also, if the examiner asks for it. Now, let's move on to this question, the last question for today. I know you guys are tired, I can understand it, but these concepts are difficult, they need to be taught. In the diagram, AB is 8 centimeter. I can see that. BE is parallel to CD. That was the beginning of our example. First of all, write down which two triangles are similar. So triangle ABE is similar to triangle ACD. AB is to AC. Write all the things down without even reading the question. You just read the first line. That is the same thing as BE is to CD. That is the same thing as AE is to AD. Done? Now it says, as such, this is not a vector question. I think it was just included by mistake, and I thought a vector might be coming up. No, there's no vector coming up, but I can assign some vectors to it. Let me first do it the normal way. What is AB? 8. What is AC? That's 8 plus 3, which is 11. Do we have BE? No. Do we have CD? No. Neither are they asking. They're asking what's the ratio of these two. The ratio of these two is 8:11. What is the area of triangle ABE? That is the small one. To ACD, that's the big one. So area of triangle is 8:11 square, which is 64:121. Straightforward. And then it says, okay, what is the ratio of triangle ABE to the quadrilateral trapezium. Well, this was not a trapezium as such, so I think a quadrilateral would be better. What is the area of triangle ABE to area of quadrilateral BCDE? Now the whole thing was 121. This thing was 64. This is 121 minus 64. How much is that? 57. That means ABE is still 64 and BCDE is 57. What special name is given to the quadrilateral BCDE? Yes, it's a trapezium because there is one pair of parallel sides. So ours was also a trapezium. A lot of people, they have this logic. They think that this is a trapezium and this is not. I mean, there are all kinds of people in this world. A lot of people, they think that this is a trapezium, but this thing might be a trapezium, might not be a trapezium. This is also a trapezium. As long as there is one pair of parallel sides, these are trapezium. Over here, the height is this. Over here, the height is this vertical line. Done. Now, how could this be a vector question? This could be a vector question if they would have said this is 8A or 8P and this is 3P. So AB, let me write it on the next page. Vector AB is given as 8Q. Vector BC is given as 3Q. Rest of the question is the same. Rest of the answer is the same. Because as long as their ratios are adding up, AB vector is to AC vector, that is 8Q divided by 11Q. The QQ cancel out, you get 8 is to 11. The vector BE is to CD, that's 8 is to 11. And then this ratio is 8 is to 11 square, which is 64 is to 121. Therefore, this is 64. This is 121 minus 64, which is 57. So the last answer is 64 over 57. So we went through all these difficult scenarios, and we were able to try out one question. This one was skipped. 2 questions, 3 questions, and 1 question from the 90s. So we did 4 questions, but those 4 questions, they all involved something which from the basics of maths were needed, whether it was about collinear points, whether it was about polygons, whether it was about similarity, whether it was about locus. So inshallah, in the next class, we will continue with more and more questions. Take care. Allah Hafiz.